It's going to be called the properties of logarithms. And so in this lesson, what we're going to do is we're going to kind of bring in the rest of them, show them to you in a list, and then start to apply them. But before we do that, we got the opening exercise. And so it says use the approximations that they're going to tell us that log 2 is 0.3010 to approximate the values of the following logs. So what we want to do is we want to use the properties we've already brought up in the last couple of sections. So for example, I may not know the log of 20 without going to a calculator, but I can rewrite this as log, and I can rewrite 20 as 10 times 2. Remember, our goal in this is to use the fact that it gave us log 2 to our advantage. So now once I know that, I can expand this and I could say log 10 plus log 2, which means then we know log 10 is equal to 1, so it ends up being 1 and then plus the 0.3010. So we find out that our answer ends up being 1.3010. So same idea if we look at this one, it's just 0.2. So we rewrite this as log of 0.1 times 2. Remember, 0.1 is the same thing as 1/10. So that means we're going to have the log of 1/10 plus the log of 2. So 1/10, log of 1/10 is -1, and then we add 0.3010. And so when we do that, we end up getting -0.6990. And then for this one here, right, if we were to try to use the approximations for logs 2, that means log to the 4th power is like saying log of 2 times 2 times 2 times 2, which means I'm adding log 2 plus log 2 plus log 2 plus log 2. Right? This is emphasizing the log 2. Since we have 4 of them, it is like saying 4 times a single log 2. So it's 4 times 0.3010, and that ends up being approximately 1.2040 for the opening exercise. So what I'm going to do is I'm going to be showing you a series of properties in this lesson. And so when we look at the next slide, these are the properties. There are 6 properties, and we're just going to kind of highlight them and note them. It says to explain why each property statement below is a property of base 10. We're not going to go into that. You just need to know these log properties for the purpose of understanding. So the first one, property number 1 that we want to observe, is that log 1 is 0. So if you ever get a log 1, that is 0. If you're interested in the reasoning behind that, remember the little base is a 10. So log base 10. And so 10 to the 0 power, right? I'll just draw a little scoop here. 10 to the 0 power is 1. And so that's what sets that one apart. The next rule, it says log base 10 of 10 is 1, right? So same idea. If we had log base 10 of 10, right, that would equal 1. So, and that's because if we said 10 to the 1st power, that would still be equal to 10. For property number 3, it expands on this idea. Such that for all real numbers r, right, log r, log 10 to the r power is equal to r. And so that goes in the same idea. If we look at this perspective, remember it says log, there's a base 10, right, and then it's 10 to the r. This is when these two match. Then your answer is just going to be that exponent of r. So now when we continue to look at property number 4, it says, it looks like there's a typo right there. It should be an equal sign inside of here. Well, it should be, say, equals x. There we go. Gotta have everything there. So for any x where it's greater than 0, if you have 10 raised to the log x as an exponent, then the answer is just x. The next property, let's see, where's it hiding at? Right here. Is that if you have the product of x times y inside of a log, that is equating to the sum of each one of those x and y's logged individually. And then our last property is going to be if we have a log x with an r as the exponent, we can move that r to the front as a product. So it can be rewritten as r times the log of x. So what we're going to see in this section is we're going to see these properties just play out, and we're going to model some of them at work. So these are your 6 properties. You want to note them. They're also in your lesson summary, by the way, at the end of this lesson. So if you want a quick reference, they're in a little box at the end of this section. So in number 7, what they want us to do is they want us to apply the properties of logarithms and rewrite the following expressions as a single logarithm. So right now, as you can see, we have a log and another log. We see that we have a plus sign right here. We have a log, and this 1/2 is multiplied to this. So our goal is going to be to reduce this or simplify it. So if this is in the front, the log property I can use, I can move this back in top. So I could say log with a 25 to the 1/2 power. And then I could say plus log 4. That's one thing I can do, so that gets rid of the 1/2. If I don't like the plus sign, then I can rewrite that plus sign, right? Plus sign changes to a product for logs. So I can say the log of 25 to the 1/2 power, and I can multiply that by 4. So now into a single log. So now we're just going to see if we can simplify the inside. So the 25 to the 1/2 power, in other words, the square root of 25 is 5. And so 5 times 4 is 20. So we end up with log 20. So same idea if we look at letter B. We can take this 1/3 and move it back in with the 8. So I have log with an 8 to the 1/3 power plus log 16. The plus sign says I can change it to product. So log 8 to the 1/3. Let's fix that 3. And we're going to multiply that by 16. So it turns out the cube root of 3 is 2. And so 2 times 16 is 32. So we end up with log 32. Same idea here. We can move the 3 to the inside with the 5. Right now, if we start to combine steps a little bit, we can also note, just so I'll do this for this one, if this is a plus sign, then I know that I'm going to also be multiplying by 0.8, or we could just say 8 over 10. We'll reduce that in a minute. So the 5 cubed is going to be 125. So we get log 125, and then 8/10, a 2 goes into both. So a 2 goes into 8 a 4 times, not equals. So we get 4/5. Now if we multiply that together, we end up getting 2. So let's see, 125 times 4, divide that by 5, and so we get log 100. And then it turns out that log 100 is equal to 2. Again, if I illustrated that, that would mean I could rewrite this as log 10 times 10, which is the same thing as saying log 10 plus log 10, which is 1 plus 1, which is equal to 2, just to illustrate that out. Or you may have noticed from our previous studies that log 100 is 10. Another way to look at that just for fun is I can write log, I'm going to replace 100 as 10 squared. And so the 2 can go to the outside, so 2 times log 10, and log 10 is 1. So 2 times 1 is also 2. So that's another way about going and simplifying that particular one out. So in number 8, what they want us to do is they want us to go the other direction, and they want us to expand this as a sum of terms involving log x, log y, and so forth. So what they want us to do is they want us to expand this out. So we could do that. This is all multiplied, so we can write log, and then we could put 3, and then we put plus log x squared, and then we put plus log y to the 5th. And so we're almost there. We want to take these 2 and this 5 and move it out front. So our final answer becomes log 3. We move the 2 out front, so plus 2 log x, and then plus 5 log y. That would be an expanded version. So now if we looked at the next one, we've got this square root. So first we're going to rewrite this, because all of this is square rooted. So we'll say this is log with an x to the 7/2 power times a y to the 3/2 power. Now we can expand this. We can rewrite this as log x to the 7/3 plus log y to the 3/2. Why don't I have a thirds up there? I don't know. This should be a 2. That is a 2. And then we're going to take and move this out front. So this becomes 7/2 times log x, and then plus 3/2 log y. So that is the expansion there. Looking at number 9, they want us to solve each of these using properties as appropriate. So and everyone has a different strategy. So if I look at this one, the easiest thing to do would be to say 10 to the 10x power, and I change that 100 to a 10 squared. Once the bases are the same, the only part I'm interested in is the exponents. And so now I could just say 10x equals 2. And so therefore I find out that x will equal 2 over 10, which will equal 1/5. So in part B, what's going to happen is we've got this more interesting piece going on here. And so one of the things that I can do is I can log both sides. So if I was to log this side, and I log the 1/10 to the x plus 1, right, on both sides. This is going to allow me to cancel some info. By the way, since this is 1/10, I could pull a negative out. And so what we end up with is we end up with x minus 1, because this part's going to cancel this part. And then this is going to become an equals a negative with a parentheses with an x plus 1. So now that we have that information, we can solve. So we end up with x minus 1 equals negative x minus 1. We add this over here, we get 2x. We add this over here, we get 0. And we find out that x ends up equaling 0. And so if we look at letter C, and we may do is let's duplicate this slide. Let's give it some room to do letter C. Let's take this off. Here we go. All right, so let's talk about letter C. Right, letter C says this: 102x. So we're going to write it up here. We'll take this. I'm going to write up here. 100 to the 2x equals 10 to the 3x minus 1. So what we'll do is we'll rewrite this. So we have, we can move this, we can log both sides. Equals log 10 to the 3x minus 1. We can move this 2x to the outside. That gives us a log 100. We can move this to the outside. So you get 3x minus 1 and a log 10. That'll go away in a minute. So 100, log 100 is 2. And then log 10 is 1. So you just end up with a 3x minus 1 on this side. So then you get 4x equals 3x minus 1. We subtract this. We find out that x is equal to negative 1. Now if we look at the last set of examples, exercises, they say solve the following log equations. And these answers will have logs in them. So what we'll do is we'll end up logging both sides. So for part A, we'll do log 10x equals log 2 to the 7. So we move this x to the outside, and log 10 is 1. We move this to the outside, so you get 7 times log 2. This is our answer, is 7 times log 2. We're not going to approximate for this exercise. So in part B, right, if we log both sides, log 10 x squared plus 1 equals log 15. So we move this out to the front, so you get x squared plus 1. The log 10 cancels, and you get log 15. What we're going to do is we're going to subtract 1, and then we're going to square root. So x is going to equal the square root plus or minus in the front with a log 15 minus 1. And then if we do letter C, we're going to again log both sides. Five with a 3. We're going to move this x out front, so x times log 4. We can move this 3 outside just to mirror that work. And if we're trying to solve for x, we're going to divide log 4 on both sides. So 3 log 5 divided by log 4 is our answer. And let's go back and just box this one in for consistency's sakes. So that ends up being our answers if we don't approximate and leave it in terms of log notation. So that's the end of lesson 12. And so if you need to rewatch it, go ahead. If not, move on to the problem set.